A very good afternoon to everyone assembled here. So without much delay, I would start my session on the search and rescue robo, precision robotics for hazardous environments. Next slide, please. So we are, robotics and AI, both looking into hardware as well as the software. So we have built in the past 10 years so much of hardware, right, that we got expertise in autonomous navigation, object detection, identification, product design and manufacturing, manipulator design and fabrication. In fact, the robo we brought, it's entirely built from scratch, both the chassis and the electronics, the control and the manipulator. Then IoT embedded systems and PCB design and fabrication. Some of the controllers in the robo are fabricated in India. In terms of software, we have developed expertise in ML and DL algorithms, HRI, natural language processing, speech to text, face recognition, and also mobile app. Now we are focusing on the three major areas, that is healthcare, agriculture, and disaster management. Currently, we have 32 researchers and 5 PhD students. We promote a lot of undergraduate research. So we can see that we have published more than 300 papers, out of which 200 publications from the undergraduate researchers. And we also have a lot of alumni supporting for our work, almost 120 from outside India. Then 14 patents within India. We got 7 granted and 2 US patent already awarded. And then we have several international recognitions and several funding from IEEE for exclusively for student projects. And other projects with the government agencies and other industry, we have completed 12 crores worth of funded projects. Currently, we have, this only I'm talking about my research center. I'm not talking about Amrita. Amrita has 300 university collaborations and 500 industry collaborations. So I have very few as of now. University of Georgia Tech, Dayton University, and SUTD Singapore. One more added from Thailand. And then industry collaborations, Megara Robotics, LionsBot, Marico, and Valio. Now, this is where we are going to start. So, the problem statement, we all know the disaster hit area. Actually, we did not come up with the problem statement to design this robo, because the robo was originally designed by a group of bachelor students in 2018, when we were planning to take part in the RoboCup German Open, which was held at Magdeburg, Germany. So, the problem statement was well defined by them. All right, so we have to build a robo based on the problem statement that the robo should be helpful or perform tasks and chores, including navigation and then all other stuff, identification, all those stuff, right, that were very well defined and listed. So that is how we started this, right. I'll show some of the video, the original one that we started, right. So even though it was for a competition, right, as most of the projects or all the projects in our research center is focused towards the humanitarian cause, this aligned well with what we were doing. So with the funding from the university, we were able to build a robo within 3 months and take it for the competition. So now current robo, right, we have multiple features added to that, right. It can it can identify or recognize or find toxic gases, then unstable debris, slippery surfaces, and then poor visibility. All these issues are taken care in the current version. Then multi-terrain driving capability. Now we have the track belt for the stability, right, which enables for navigating various surfaces, including the stairs, oily areas, and rocky terrains. Then flipper mechanism was again and again fine-tuned. This is the 4th version of the robo that you are seeing currently. Of course, we had to suspend this for some time during the COVID. Otherwise, we were continuing. So we are currently focusing on the human detection using thermal camera and CO2 sensor. So if any of you are interested in collaborating with us, because this is one critical area where we found that now even recent landslide at Wayanad, no, our robo could have been much of help if we had completed this on time. This is still under research using the thermal camera and CO2 sensor to detect the human under the debris. No, so that is one important thing of this robo. Then many MLDL algorithms for object detection, sign detection, human detection, etc. So these are some of the current version you can see on the right hand side, right? So that is the one that we took to Japan 2 weeks back for taking part in World Robo Summit that was held at Fukushima, the disaster hit area. Some of you might remember in 2011, 3 disasters struck Fukushima simultaneously. One was earthquake, tsunami, and nuclear disaster. So the government of Japan is investing a lot in finding out solutions to use robots to overcome these difficult times when severe disaster hit these areas. So they have invested more than 100 crores of rupees, built the first in the world class for entirely for robo testing and drone testing. So it's a test field in Fukushima covering around 50 acres of land. So out of, there were 10 teams all over the world. We were one of the teams taking part in the competition. So I'm not going to go much through the specification, right? So except that the weight of the robo, the chassis alone is 35 kg and the weight of the robotic arm manipulator 16 kg. As I mentioned earlier, everything is indigenously built except for the actuators that we had to depend on because India does not make such sophisticated actuators. Right. So this, we had a lab test at our lab facility, but we did not know, because this is the first time we went to Fukushima. We have been in World Robo Summit in 2018 and 2021. 2021 we participated online. 2018 we went to Japan. At that time it was held in Tokyo, but it was in a controlled environment, right? It was artificial setup in an arena or a trade fair center. But this time, it's a real, what you see is a real factory. That is, the robo is on the ground floor of a 6-story building, which represents a factory, and each story, right, had a different type of accidental setup. The robo had to navigate all the 6 floors and complete the tasks, right? So this had given us a very good exposure and experience for us, where we stand with respect to the design, with respect to the testing that had happened, because what we did in our lab is no way comparable to what we had seen at the real time. So this is a video that you can show from the original version. So this was the 2018 built by a group of students. So this where we are taking part in the competition, this artificial setup. So the second version, this that we went to take part in WRS, World Robo Summit 2018 again. So again, this is an artificial setup. Oh, sorry, it was 2019, not 2018. So this was the third version that we built, and we took part in 2019 RoboCup German Open. So this is during the tsunami, because we couldn't go right to Japan because of the restrictions. We had to set up a test arena at our campus in order to take part in this competition. Right. So this is not the test setup yet. This is like we are testing. You can see the robo is able to open the valve and all. So we will move on to the next one. So this Magdeburg that we took part in 2018, and again this is 2019. So it's not 18, 2019. We had taken part in 2 different competitions. Now this is a video, as I mentioned, that during the tsunami, we set up at our campus, right, where the robo, you can see the operator cannot see the robo. He is inside a closed room where the only way to see is what the robo sees, right? Whatever the robo sees, it has 2 cameras. That is alone the operator can see. He is in a closed, I don't know how to play the video. Yeah, so he's a closed environment. So this is in a setup that where the robo has to navigate through these hanging pipes, because in a disaster hit area or in an accidental setup, right, so the pipes might be hanging, right, and the robo has to navigate through this congested space. Right? This is only one test setup you are seeing. Behind that, you can see there is a small QR code, right, that's set up where the robo has to go and identify the QR code and send the coordinates and also the what the QR code meant. Now, this is another setup where the robo has to climb steps up and down multiple times. So these are some of the setups that we had created at our campus in order to take part in the competition. So this is the World Robo Summit that recently, we went to 8-member team took part in the competition. We were inside a tunnel here, right? They set up a huge tunnel of half a kilometer, a real-time tunnel, where if accident happens, if there is no light, how the robo behaves. If there is smoke, how the robo behaves. So all that we need to go through. So this is at the site when we were testing. So we had to fix the light because it has to navigate through the smoke or fog, or even in the failure of electricity, like in kind of inside the tunnel. So this is some testing that during the initial stage of this final. So this is the 4th version of the robo, what you see. Okay, I'll skip the video due to the time limit. Okay, I think we have come to the end of my presentation. 1 minute left, so if any question is there, I can answer.